You probably heard about the asteroid called 2024 YR4, which became famous after it was discovered by the NASA Atlas system on December 27, 2024. According to initial calculations, this asteroid of considerable size will get uncomfortably close to Earth on December 22, 2032. Fortunately, now we know this is not the case. Although now NASA has reduced the probability of impact of this asteroid to almost zero, identifying these potential hazardous objects is critical and key to NASA's Planetary Defense Coordination Office, which manages agency efforts to find, track, characterize, and if necessary, mitigate against near-Earth objects' impacts. The story of how the news about this asteroid propagated and the reaction of the astronomical community is an example of how prepared we are or want to be to tackle a problem like this. That is why on January 31st, 2025, when the available observations indicated that the asteroid reached 3 on the Turing scale, which meant it had a 1% or greater chance of collision that could cause local damage, it got the attention of the astronomical community. Of course, astronomers worldwide took action by making a series of observations to confirm or rule out the risk. By March 26, 2025, experts at NASA Near Object Studies had 476 observations of the asteroid, allowing them to calculate more precisely models of the trajectory and updating the impact probability to 0.004% or 0 on the Turing scale, with no significant potential for this asteroid to impact our planet in the next century. However, this asteroid still has a very small chance to impact the Moon on December 22, 2032. That estimated probability is currently 3.8%. Some of the observations used by NASA came from the James Webb Space Telescope, which, thanks to its infrared capabilities, allowed astronomers to determine the size, shape, and composition of 2024 YR4 asteroid. Initial analysis of the JWST data by the astronomers at the Johns Hopkins University Applied Physics Laboratory indicates that the size of this asteroid can be constrained to about 200 feet in diameter. This size is consistent with other observations that it is an S-type asteroid made mainly of iron and magnesium silicates and a surface probably dominated by rocks that are maybe fist-sized or larger. To track asteroids like this, the international community continuously scans the sky in search for potential threats to Earth. For more information, you can refer to international and use-based projects. And just to give you an example, NASA Atlas comprises several telescopes around the world and provides a warning time depending on the size of the asteroid. Atlas will see a small 60-feet asteroid several days out and a 300-feet asteroid several weeks out. If you like the information in this channel, please remember to subscribe and follow me.